Okay, now you've written that down. Let's have a look. This is a frequency distribution of job salaries in the UK for people with the word program in the title. As you notice, the average is about 45k. Now, is that higher or lower than what you were expecting it? If it's higher, why do you think developers are actually willing to pay these kinds of salaries? Look at it, 80k, 100k. Why are they willing to pay these kind of salaries to people? They're paying them to people not to just do what they're told, they're paying them to people to actually solve problems. And that's what they're looking for, particularly at this top end. You really want people to solve. And this is the kind of area that Google pays, particularly for the top end programmers. Remember, programmers have a 100-to-1 ratio in terms of performance. So the best programmers are 100 times more productive. They write 100 times more code than poor programmers. So the people at this end. So they're looking for these kind of people. And in order to do that, they've developed this thing called the Google style interview. These are the kind of salaries in dollars that people can earn. Was that average, the 80,000k, higher or lower than you expected? Now, you'll notice that some of those salaries go all the way to the top. 200k, so you're looking at $250,000 per year. To get the best, people have invented this thing called the Google style interview. For any job that requires more than a pittance, they're going to test your programming skills. At the top end, they're going to give you a Google style interview. Please follow the links in the YouTube video to see the one in action. It's definitely recommended watching. So why they do this is because plenty of graduates from a computer science course graduate and still don't know what they're doing. So they want to filter out all the dealers and hangers-on, all the people that got someone else to do their homework for them. What they will do is normally give you an algorithmic problem. They'll give you a whiteboard and a pen and ask you to solve a problem there and then in front of them. So for example, in some case, they'll give you a list of numbers, and when you reach the end of the list, you'll come back to the beginning of the list. It's a circular list. And they want you to find the minimum number in the list. So if the list of numbers is, the list of numbers is always either increasing or decreasing, but it's circular and it goes back to the beginning. So part of this course, I want to prepare you for these kinds of interview. Now, typically, they won't ask real-world questions during an interview. That would be far too complicated. They just want short little puzzle programs that you can quickly master and demonstrate your understanding of algorithms and data structures. Precisely what we're teaching on this course. So basically, in 18 months, you're going to go out and you're going to be buying these kinds of books. If you're smart, you buy them before you go to the first interview. So you're going to be covering everything in this course sooner or later. So why not make it sooner when there's people like me around who can give you a hand? Okay, that's the motivation for the slackers and the hangers-on. But for the rest of us, algorithms and data structures are the true soul of computer science. They are the very essence of what we are doing when we are coding. I'm going to focus on the stuff in this course which is the most useful on a day-to-day basis, and it's about making your code faster and stronger, more powerful and more reliable, and most of all, easier to write. I'm going to teach you practical tricks of the Java masters. More importantly, we're going to look at fundamental examinations about what's going on behind the scenes to show you some of the most powerful things available to you when you're coding. I always strive in this course to make things as simple as possible. I like to get rid of mumbo jumbo and needless maths to give the essential idea of what's going on. Unfortunately, there's still stuff at the bottom you need to engage with, and the best way to learn is to do and never stint on doing. The bottom line is, this is the soul of computer science, and I want you to pick up the fever. What we're doing isn't always easy, but there's a certain joy of getting your head around an algorithm, and I want you to have that joy, but it doesn't come without any effort. Motivational speech over, but at least we have some idea of why we're learning all this work. If your Java has become weak over the summer, I would suggest you go out and try to engage with Java again. Build something, build something in Java. However, this course is also designed for the number of visitors who haven't programmed in Java before. This is why I stress we will be using pseudocode. Time and time again, I've seen students who can't program in Java try to engage with a Java programmer. It's too late. You can't jump into the deep end and think you can swim across the channel before you've even learnt to paddle. Either you need to get your Java programming skills up to speed, and this is going to help you for the rest of your life, or you're not. The good news is, if you don't want to engage with that, that's okay. We can get through the entire course in pseudocode. So, for all of the programming assignments, if you cannot do the coding in Java, do the coding in pseudocode. This is not a Java assessment course. Java is merely a facilitator to actually get somewhere. It's easier in Java because the machine can tell you if you're going wrong and you can test things, but I'm totally willing to accept material written in pseudocode. I've had a lot of people over the years submit code that doesn't work. That's completely useless. There's no way we can evaluate non-functioning code. If they, however, had submitted some pseudocode, they would have passed fine. So don't make yourself miserable, do pseudocodes. To be honest, most professional programmers over your lifetime will be learning 5 or 6 new programming languages. So knowing how stuff is done in Java or Python doesn't really help. Java isn't that important. By the time you retire, Java probably won't exist any more than COBOL exists or Fortran exists now. Everything we are teaching you at the moment has an expiry date. The good news is the pseudocode will live on forever. It's small, compact, and most of all, a very high-level description that's portable between programming languages. So while I'm emphasizing on the utility of Java programming libraries, you need to try and think about the underlying principles to understand how they're working. I tend to simplify things down so they can be understood. I like to make my work engaging, relevant, and interesting. This isn't for everybody. They like dry, dull details, and that's okay. In the library waiting for you now, virtually or physically, there are a number of books on data structures and algorithms in Java. We're currently recommending the one by Goodrich, and this is currently the course textbook. It is traditional in most universities to go out and buy this book if you don't have it yourself. And it's traditional when you start your first job to put it on the shelf next to you so you can then suddenly go back and go, oh, I seem to remember we did something about this once a long time ago. Don't believe in Googling everything. It won't work. I'm also recommending Java Collections because it's neat, compact, and if you want to go out and buy a book, try Think Data Structures by O'Reilly. I'll be giving you the page numbers of the primary textbook as we go along. Let's have a look at what's happening over the weeks ahead. We're going to start off with binary search, recursion, and O notation. Those are the real basics, and that'll get us warmed up. My hypothesis there is actually you know the solutions already, you just don't know you know them. Week 2, we're looking at sorting and comparing. Again, bit of a tradition, but again it allows us to see how different algorithms can operate in different ways. Week 3 should be a bit more relaxing. We're looking at arrays and generics. This should get you up to what generics are, as revision from last year, and actually arrays are the most common form of data structure used throughout programming, so it's good to get a good idea about that. We're then going to use an alternative version of the array called the linked list. Not so useful, but actually it provides the useful foundations for the later data structures. Hashes and maps, they're the big ones. They are where the real source of speeds up come in a lot of everyday code. You've looked at hash maps already, but you haven't really looked at hash maps already. Queues and stacks, they're really useful, they're really handy, and they are great abstractions, and it shows us the power of abstractions and data structures. Then we'll be looking at our friends the trees. They're again incredibly powerful, and they're definitely worth attending to. Then we'll be looking at sets and the abstraction of sets. Now that's going to be really useful, and again, if you can see the analogies between what we're doing here and what you do inside, say, SQL, you will be streaks ahead. Then we're going to take a slight break and look at why slow is good. Sometimes you cannot speed an algorithm up, and strangely, there are some very good uses for that. This, at this point, is all we've done all the stuff that will be assessed. Everything else, it's kind of optional, but actually it's the sort of thing that really does appear in lots of interviews. Then we'll be looking at my personal favourite, graphs and networks. They're incredibly powerful and they give a great insight into an awful lot of modern society, strangely enough. Then we'll be looking at one of the great hacks into how to speed up programming. We'll be looking at dynamic programming. And then finally, I'm going to keep that as a bit of a secret, but we're going to look at how to solve the kidney patient problem. The other thing is, the learning isn't just happening in the lectures. There's going to be lots of stuff we'll be introducing in the workshops. It's going to be very useful. The key one of which is we're going to be looking at using a profiler. That's an absolute must. And it's also going to be the assessment, so it's definitely something you want to engage with as well as you can. Okay, that's enough of that. Let's move on to the assessment. Obviously, because of things like the pandemic, it's very hard to be 100% up at the time of recording about the assessment process. I can give you a broad outline of what's going to happen. There's going to be two halves. There'll be the design project and the code project. The code project is the need for speed side. It will probably be handed out near the beginning of term, and there will probably be a hand-in near the end of term. It'll probably be project-based, so you're going to have to build something or rather fix something, and there'll be a workshop on week 12 for people to try out their various speed improvements. That's as much as I can give you. I would definitely pay attention to the assessment system and on Blackboard to keep an eye on what's going on. We will keep you up to date with any changes that have been made. Do keep your eyes open and I will try and update the slides if at all possible to keep you aware of what's going on. Okay, let's move on to the work. Okay, let's get started. Normally, I do this in a full lecture theatre. So you're going to have to pretend to do this or do this with someone in your household now. We're going to play a game. It's a game of two players, player A and player B. Player A guesses a number from 1 to 256, and player B can ask yes/no questions of player A. Each question costs a point, so it's a bit like Hangman. So for example, a question might be, is it 340? No. It's like, is it 34? Yes. Okay. So I want you to sit down now and play that game. Okay, stop. Here's a new twist. I want you to write down your method that you've figured out as pseudocode. And then once you've done that, if you're playing with a partner, I want you to swap methods. So player B has done the same kind of writing down, and you're going to swap around. So you're going to play the game again, but player B can be pedantic as they like with your pseudocode. Try that again, and then enter in the pseudocode in the box below.